Well, good afternoon, everyone, and welcome to today's webinar on energy management and AI, where we'll explore how smart technologies is transforming the way organizations manage energy and boost efficiency and build more sustainable systems. The agenda for today, we're going to look at what's new from Enova. Uh, Up after that is our main event, and then at the end, we'll always have our Q&A session. So, what's new from Enova? Well, giving back to our community is one of our main focuses. Over the holidays, the staff raised $1,800 for the Region of Waterloo Holiday Family Campaign. It's always well received and well funded. Uh, we're also going to start Enova's Elementary School Electrical Safety Art Contest. That's kicking off shortly. The contest asks students to show their creative side and spread the word about electrical safety by creating their safety-themed work of art. This year's contest theme is Indoor Electrical Safety Tips and Tools. The winners are selected through an employee vote and an online public vote. We'll use the winning entries on social media, our website, bill inserts, ads, and other communication materials. Future webinars are going to consist of the Save on Energy program, the expansion of the energy management programs. There's going to be a webinar on the solar photovoltaic DER program. So the Save on Energy, with the financial support from Natural Resources Canada as part of its Green Industrial Facilities and Manufacturing program, is expanding its energy management program. The enhanced offer will help industrial facilities in Ontario improve their energy performance through energy saving opportunities in 4 areas: funded energy managers, strategic energy management cohorts, and curriculums. We're actually planning a webinar on how SEM program can help meet your electrification decarbonization targets. So keep your eyes open for that invitation. Energy management information systems, which we're all gathered here today to talk about that, and energy practitioner training, such as the CEM, CEA, CMVP. The solar photovoltaic DER program is basically any system that's under 10 kilowatts. The ISO will incent each kilowatt $1,000 per kilowatt. Any small and medium-sized generation projects greater than 10 kilowatts up to a megawatt are eligible for $860 per kilowatt. This is not for net metering. It's totally for low displacement purposes. And as always, let us know what topics you're interested in learning about, either controls, HVAC systems, EV charging, electrification, decarbonization. Either contact Andrew or myself, and we'll get a topic expert to present. So just a friendly reminder, we're here to support. Andrew and I are always here to help as your dedicated key account advisors. We offer a range of services designed to simplify your energy management and maximize values. We're your single point of contact within Enova, so use us. We conduct energy usage analysis, billing analysis. We help our customers make informed decisions. So, for the main event, we're excited to explore how smart technologies are transforming energy use, boosting efficiency, and supporting sustainability. Joining us today are 2 experts from Edgecom AI, a leader in AI-driven energy innovation. First, it's Bedad Barami, who is the co-founder and CEO of Edgecom AI. He's with over a decade in the sector. He's led major projects, including Ontario's Battery Energy Storage Initiative, and was recently named Energy Innovator of the Year 2024 by the Association of Energy Engineers. Courtney Conway is the operations manager at Edgecom. She holds I believe that's Bachelor of Science in Physics and multiple certifications in energy management and sustainability, bringing both technical expertise and strong passion for clean energy. we mentioned before, feel free to drop questions in the chat. We'll have a live Q&A at the end. So throughout the session, so grab your coffee, sit back, and get ready to discover how AI can unlock a smarter, more efficient energy future for your business. Please join me in welcoming Bedad and Courtney.
Right, thank you, Chris and Andrew. So I'm going to go ahead and share my screen so you can see our presentation here. Just let me know when you got this on your screen.
Perfect.
Yep.
Okay. So as mentioned, today we're going to talk about energy management and AI, specifically how to unlock the future of energy management with AI. And we did have a brief introduction, but we'll just introduce ourselves again.
So hi, everyone. My name is Bedad Barami. I'm the co-founder and CEO of Edgecom. Before launching Edgecom, I was actually an embedded energy manager at one of North America's largest plastics manufacturing facilities. I saw firsthand all of the challenges and all of the issues energy managers face when it comes to aggregating energy data and gathering energy data and making sense of all that information. And that was really the idea that culminated into launching Edgecom back in 2016. So I've spent well over a decade in the energy space. And I think we're just getting started when it comes to the energy transition and energy optimizations. And I'm excited to share how AI is going to accelerate that today.
And I'm Courtney. I'm the operations manager here at Edgecom Energy. I've been here for about 4 years, so I've seen a lot of our products and services grow, as well as seen our customers grow in terms of what they're doing with energy management and their data with AI. So we'll start off by talking about data in general and what that means with energy management. Right now, there's a few limitations that we're seeing, and we've heard from our customers as well as experienced ourselves. So the first one is lack of granular data. So many facilities focus only on total consumption and lack any data on downstream assets. Right now, most people are getting a lot of their information from their bills. The utilities have been great in terms of offering portals to view that data as well, but that limits you to your utility data, not so much what's happening downstream on individual assets like chillers, boilers, even production lines. So that's the first limitation that we feel strongly about. The second one is tedious data collection, especially if you're somebody who manages multiple facilities. As I mentioned, there are utility portals available, but if you have 5 different facilities all under 5 different utilities, then you're going to have to go to 5 different portals to actually extract that data and then analyze it further. Which leads to the next point, too much data to process. So once you have all that data to your disposal, now you have to work with it. A lot of that comes along with different types of formatting, different calculations, Excel, which is everyone's best friend. And then that leads to our last point, which is time-consuming data analysis. So once you have the data, once you've put it into your calculators, there's still a level on top of that, which is actually analyzing it and understanding it and pulling insights for your facility directly. So that could be a challenge sometimes, especially with the last 3 steps. Analyzing large data sets and extracting useful insights is time-consuming and requires a lot of expertise if you don't know exactly what you're doing. You might need to pull in someone from a different department. You might need to reach out to a consultant. So these are 4 of the main points that we've summarized that are difficult when it comes to energy data.
So you have 2 ends of the spectrum. You might have some facilities where they have too much data, and in many cases, you also have facilities where they have not enough data. Finding industrial and large energy consumers that are sort of in the middle, where they're in that sweet spot of having the right data, having the right amount of data, is very, very rare. So either you're on one end of the spectrum or you don't have enough data to make sense of it and to analyze it. So usually, in most cases, the energy data that a facility will have, most facilities, is an energy bill. Now, what's the problem with an energy bill? Energy bills are great. They give us the kilowatt hours. They give us the global adjustment. Well, the problem is they're delayed data, right? So any action that you're going to take in your operations, you're not going to see the results of that for at least 31 days, in most cases around 45 days until you get the bill for the last month. So any initiatives that you would have done, everything is kind of already outdated. At the same time, there's all these line items on your bill that you might not really understand, right? So everyone sees their bill, everyone looks at it, there's global adjustment, there's HOPE, there's your distribution fee, various charges, But each of those charges is actually a controllable cost for energy intense facilities. So how many people can really say they're an expert in a typical Ontario energy bill? Not many, right? So as someone who spent over a decade in the space, it took me a long time to wrap my head around all the different intricacies. And it's always changing and dynamic as well. So there's a lot of data on bills, but it's outdated. And then you have to know what all those line items mean and how you can impact those line items as well. So one end of the spectrum, you might not have enough data. Then there's the other end of the spectrum, more sophisticated customers that have way too much data. So they went through an EMIS, an energy management information system installation, or they have multiple sites, a campus with multiple buildings or multiple sites spread throughout the province or throughout the country, and they need to gather all that data and make sense of that data. Now, what are the different types of data that you need to have in order to optimize your energy? So there's different silos of data that need to come in, and you need to process these, and you need to cut across these silos to be able to make sense of it and to actually gather energy insights out of it. So the first data that usually you start with, and the first data that's available, is your facility data. This is the real-time insights that you need to have of how specific pieces of machinery in your operations are running, how specific buildings are consuming energy, live data, not outdated data, so metered, sub-metered energy data. You need to be able to take that facility data and you need to baseline it against your production or occupancy or weather, whatever type of independent variable that you might have in your facility. So you can imagine how aggregating and collecting that data might be very time consuming and very cumbersome if you don't have some automated systems in place. So gathering the production, occupancy, that independent variable that you need to compare energy to, that's pretty challenging. The next thing you need to have in order to be able to optimize energy is weather data. So hot and cold days obviously drive huge impacts on how much energy we consume as a province. The sunshine boosts the solar output, the embedded solar generation changes, rain will cool demand. So weather, but not just temperatures, actually rain events, snow, all of that has a huge impact on the overall energy consumption in the province, and the data will impact the analysis that you will need to do on your operating energy data to be able to make the right decisions. Then you have billing data. So billing data tells us what the costs are, but again, they have multiple line items which are quite complicated. The rates are complicated, understanding what the drivers of those rates are. So is this rate a rate that is dependent on kilowatt hours of consumption? Is it dependent on peak consumption? How much effect can I really have on this line item on the bill? And what should I do to impact that? And how does it interplay with all the other various data that we have? And then finally, because the grid is very dynamic, and with the market renewal program here in Ontario, it's going to get even more dynamic, you need to have hourly price estimates, demand response events, coincident peak events, all of that data plus more analyzed and brought into one place. Now, can you imagine one person trying to wrap their head around all these data sources coming at them from multiple buildings in one go and trying to make decisions off that? It's very, very challenging. So you either have too little data or too much data in most cases.
This brings us to the introduction of benefits of AI. So where does AI fit into this? It helps with the democratization of data. So it can provide an interface where non-data scientists can analyze and access real information. So I'm assuming that some people have already heard of things like ChatGPT and other AI platforms where you can easily just go in and ask a question because it has a whole bunch of data available to it from the internet. So the same idea can be used in terms of energy management as well. When we have a whole bunch of data, we can actually use AI to kind of filter through and get the answers to the questions that we want. Additionally, enhanced operational efficiency, so significantly reduced data analysis and communication time. So again, if you have kind of this central source where you can ask questions and get the answers to the questions you want, it might not just be you. It could be other people in your company, other facilities, other people within departments. So for example, if you're an energy manager and maybe you want to pass along information to someone in the finance department or operations, instead of manually having that data travel to different departments, you can actually just have one single place where they can actually ask those questions and get the answers. Which then leads to the final point here, which is better decision making. Not only better decision making, but I think faster decision making as well, because you're kind of getting rid of those legs of communication. Sometimes people are away, sometimes they don't check their email. So again, having that one place creates a more efficient way to get data. So as we have here, instant access to energy and carbon insights, as well as report generation for energy costs and emissions. We're already being able to see how AI is able to create visualizations very easily. This can also be used for energy data as well as instant answers specific to your facility. So again, as we mentioned, you might have too much data, maybe you have too many properties you're looking at, and it gets a little bit difficult to actually zone in on one of them and actually get the insights that you're looking for. But if you have all of this in one place, and maybe you can use AI to get those insights individually and a lot faster.
So really what AI does is it unlocks the opportunity for energy optimization, which leads to more efficient consumption of energy, optimized consumption of energy, and lower costs and lower emissions. So there's quite a few ways that these newer versions of AI, which are called LLMs or large language models, can come in and improve various things that you need to do in order to optimize your energy consumption. The first one is energy forecasting. So it's very important to be able to take that weather data, take that demand data, and have an idea of what the future is going to look like on the grid. If you know that prices are going to be peaking tomorrow at this time to that time, or Wednesday of this week is going to be a time where the grid is going to be very, very expensive or very, very dirty, then you want to make some decisions in how you run your operations that will save you costs and reduce your emissions. So being able to forecast energy is very important. There's many, many people out there that are trying to tackle this problem of accurate demand forecasting, both on the ISO level and on the DSO level. And energy forecasting is significantly improving because of these newer LLMs and AI models. The next one is carbon emissions.
So as you could imagine, having all this data available to you is great for energy management and, as Beta had mentioned, energy optimization. But there's something that goes hand in hand with that as well, which is carbon emissions. And we're foreseeing right now that, politically and economically, a lot of companies are going to be mandated, as we see in some other locations, to actually report on their carbon emissions. So having that information readily available is not only useful for reporting that may be necessary down the line, but also for your own understanding of what you're consuming within your facility. And everyone has a goal right now to kind of get to net zero, but the only way that you're going to be able to do that is to understand where you are and what steps you need to take to actually get there. So again, having AI able to answer those questions for you and provide the data that you need when you need it can help us get onto that path.
So the next one, similar to energy forecasting, is load scheduling, right? So you need to be able to make some decisions in how you run your production and how you run your operations to be able to schedule your consumption in a way that optimizes based on what's happening on the grid, right? So again, if you know that the price this afternoon is going to be much higher than over the weekend, you want to avoid using more energy this afternoon. So dynamic load scheduling and dynamic production forecasting is something that we see happening. And finally, grid management, right? So utilities, distributors, the ISOs, they're really taking advantage of these new AI tools to help them optimize where assets are going to be installed, how to run the grid, making sure that those network operation centers and dispatchable loads that are on the grids are really being efficiently run. So markets generally are pretty efficient, but these LLMs and these new AI tools are going to make it even that much more efficient and that much more optimized.
So I spoke briefly about ChatGPT. So we're going to talk about generative AI right now. And that is a traditional AI models which focus primarily on data processing and prediction. They differ in that it produces entirely new content. So like text, images, now we're seeing audio come out of AI. These LLMs, or large language models, as we should say, are a type of generative AI that understands human language. So it can actually decipher questions and go a little bit deeper into the things that you're asking just by understanding the language that is being presented. Generative AI that understands human language, most common application is ChatGPT and other similar chatbots. Now we're almost seeing like a race to who has the best generative AI between ChatGPT and Google and all these other companies. So the capabilities that we're seeing within generative AI in itself are progressing very fast and very rapidly. They've also enabled non-technical people to interface with advanced algorithms. We're even seeing like no coding solutions where people can put an idea that they have and actually see a product being created without having to code themselves whatsoever. So the what's happening now and what we're going to see with AI is very exciting. But we need to talk about how that relates back to energy. Oh, sorry.
So there are a lot of AI tools that are available now, and these LLMs are the newest product in a set of multiple big evolutions that we've had in AI over the past 20 or so years. So we went from traditional machine learning, we went to deep learning, and then now we're at these LLM solutions. So what's the advantage and what's the disadvantage? Courtney talked about LLMs in general, but I think there's some big problems with the LLMs as they currently stand. And these are going to be problems that are very, very difficult for a general model to be able to solve. So if I'm creating ChatGPT, I want it to be able to answer the most generic types of questions, which is a good thing, but then it makes it difficult for it to have specific domain knowledge and specific understandings of specific types of information. These things are also trained on publicly available data in most cases. So it doesn't have that domain knowledge, let's say, of energy management or of peak optimization. So it has to be trained, right? It's a model that's pretty smart, but it needs to be trained. And the problem with the general models is that in many cases, you'll continue to get hallucinations. So what is a hallucination? It's when the LLM doesn't really understand the prompt. You'll never, very, very rarely will you see the LLM respond and say, I don't know the answer, right? So if it doesn't know the answer, it still pulls from its knowledge base and it just makes something up, which in many cases is a hallucination. So it's so confident in the way that it tells you that answer. So we call that a hallucination. The next part is lacking domain knowledge. So these general LLMs, they'll be able to answer surface level answers to very domain specific questions. Now, some of the models, like for example, the latest O1 model from OpenAI has been able to reach PhD level research thesis creation, but only in certain domains, right? So domains that are very text heavy, domains that are things like legal cases. It can do a great job in things that are text heavy. And things that are math heavy, they're still struggling with some of the simplest questions that maybe even a high school student would be able to answer. The other part of it is being able to create the right prompt is also not an easy thing to do, right? So it's going to get to a point where if you have to have a PhD to put in a prompt to get the right answer, then that again gets rid of a lot of the benefits of democratizing these general LLMs. So it doesn't really solve the problem in many cases because the prompt that you have to put in to get the right answer is almost like writing code to begin with, right? And then finally, lacking domain context. So the terms that we use in the industry, the difference between a KW and a KWH, so what is a coincident peak? What does peak demand mean? Those are very different depending on, are you in Ontario? Are you in Alberta? Are you in New York? So there's a lot of context that needs to be fed to these systems. And if you don't have the right context, the right data and the right information and the right insights are not going to come out of it. And in many cases, the data that you give it is not interpreted properly. So general LMs like ChatGPT have a lot of shortcomings. And this is where specific models come in to solve that problem.
So now we're going to talk a little about AI Energy Copilot, which is something that we've been working on, versus general LLMs. So as Beta had mentioned, the generative AI is very generally focused. It knows a lot, but it's not very domain specific. So when you go and ask certain energy questions, it might not give you the actual answer that you're looking for. Personally, myself, I've asked ChatGPT to do like a kilowatt to a kilowatt hour conversion, and it did it incorrectly. So that's an example of how it does not have a specific knowledge. But the AI Energy Copilot that we're working on is going to be trained on that energy data. It's going to receive real-time data from your assets. We do offer IoT sensors, which we would connect onto a downstream asset, and then that data would actually feed back into our portal, and then you'd be able to ask the AI Copilot certain questions about that asset or its energy consumption. In addition to that, there's also a direct integration with EMIS and also an integration with SCADA systems. So if you don't want to use any hardware and you already have that data available to you, we can easily just pull that data and put it into our portal or our cloud where it can actually be used with the AI Energy Copilot.
So 24-hour optimal production scheduling is something which is very exciting. So this is a part of the LLM. So what we're doing with our Copilot is we're training it on specific use cases. And it's almost like a person that you need to train and teach different skills to. And it gets this experience in those skills. And it gets better and better over time as more people start interacting with it on those skills. So the first skill that we've trained our Copilot on is the 24-hour optimal load scheduling. So what this is doing is it's analyzing what the forecast is for energy prices over the next 24 hours, and then telling you as a facility operator, a building operator, how should you run your building? So at the end of this 24-hour period, you're still getting the output that you're after. So imagine in a case of an injection molding facility, right? They want to get 500 components made in the next 24 hours. Well, when should I be running full out? And when should I be taking my foot off the gas and running my machines a little bit slower? With the Copilot, that will actually analyze your production data. It will analyze the energy forecasts, and it'll give you a schedule of how you should run operations in order to save costs, in order to reduce emissions, and you can actually interact with it back and forth and give it more information. So you could say, on Tuesday, I have an order going out. I'm not going to be able to change the production schedule based on what you've said. Give me some other options, right? So you'll be able to have literally English conversations with this optimization model that will give you the best way to run your production. So you still get the same outputs that you're after with lower costs and lower emissions. We also have tested it thoroughly on energy cost, production, and emissions questions. So simple questions about your energy consumption, the costs of your energy, your production schedules. It's able to pull that data from the database and give that information to you very quickly and easily. The next two we're working on, there are versions of this currently out, but they're in testing. So custom alerts and alarms. You can imagine you'd like to know if your main energy feed is going above 200 kilowatts, send me an email, send me an alarm. So instead of going and fiddling with very complicated notifications that are always popping up and no one really ever pays attention to them because they're always having false alarms, you could actually create custom alarms through natural language where it understands what are your concerns, what are your challenges. So on weekends, let me know if this happens. On weekdays, let me know if that happens. And over time, as you continue to have conversations with it and feed it more information, it will get, again, that experience of how you like to operate your facility, the kind of alarms that you like to have, and it gets smarter and smarter over time. So this is a feature that we're doing a lot of work on. And then proactive insights tailored to your facility. This one, we have the version 1 of this also launched on our portal. So an analysis of how certain assets operated this week versus last week. How are different compressors doing? Compressor 1 versus compressor 2. What's the comparison of these two? So proactive insights that are LLM powered that are specific to your facility. So many of these are already available, and some of them are coming out soon, and they're currently in testing. So when it comes to these LLMs and really what they enable you to do inside your facility, it always comes down to internal optimization, grid side optimization, and then we'll get into some of the funding potential as well. So when it comes to internal optimization, really what we're talking about is constant facility oversight. So imagine you have a person who's constantly monitoring various devices in your operations, constantly monitoring the main energy consumption of the main utility meter, downstream devices, looking at the price forecast for Hope, looking at the price forecast for peaks, and constantly looking at this 24/7, 365 and letting you know if anything is out of the ordinary. So that's what you get. You get internal optimization with these AI tools. You get the ability to quickly generate reports for stakeholders. So I remember as an energy manager, one of the questions that would come up all the time is, we did this lighting retrofit, how much have we saved so far this year based on this lighting retrofit? Now imagine you just go ask the Copilot that question, and something that would have taken you days or weeks or months to gather the bills, gather the interval data, put that in a baseline model, analyze that baseline model. Now you get that in a matter of minutes. All you had to do was make sure all the data is interconnected, and the Copilot will be able to answer that for you. Smart alarms. So instead of having to constantly monitor a dashboard, which nobody wants to do, nobody wants to be looking at a dashboard 24/7, you will get smart alarms. Only when things are out of the ordinary, you will be alerted. And your maintenance manager, your operations manager can run and make sure that whatever is over consuming or whatever is out of normal bounds is now taken a look at and fixed. Identifying inefficiencies and abnormal consumption. So we've had clients that were able to find during curtailment events, the devices that they thought were being curtailed were actually not being curtailed, right? Once you get interval data, you'll be able to see that days later, but with these tools, you'll be able to see that in real time and fix it for the next peak that might happen tomorrow, right? So we don't want delay in data. We want to be able to get that information quickly and take action on it right away. And then aggregating all the data from your utility, the grid, and the facility in one place. So nobody likes to work with scattered data sets. When you have all of it in one place, it makes gathering insights from it, especially when those things are related to each other and correlated, much faster and much easier. On the grid optimization side, again, you need to have live data analysis. So what are prices looking like? What are peaks looking like? What is the demand response, the potential for a demand response event? So all of these things are embedded into the same platform. And then you can go one step further, which many, many facilities are going ahead and procuring behind the meter distributed energy resources. You could think about EV fleet charging, battery systems, solar panels. All of that needs to participate in the market and create revenue in an optimized way. And AI, again, allows that to happen. And the beauty is right now through the Save on Energy funding programs, any sort of EMIS that you're looking at is 50% funded. And Edgecom's EMIS has this AI all built in and included, right? So it's not a separate solution. It's part of the EMIS bundle.
So now that we've discussed a little bit about what's currently happened and including what we also offer, what is the future of AI? So what we're anticipating to see is inter-agent communication. So AI agents will be able to share information and collaborate to produce better results. So as you probably realize, a lot of other companies are also coming out with their own AI copilots or AI chatbots. So now you're going to have a few different data sources within a few different AI chatbots. Now, how do you integrate those together? So the next step would to actually have those agents or chatbots actually communicate with each other directly. So that's going to be a very exciting, when it does happen, it'll be very exciting features to look forward to, especially if you thinking that you're going to use something like an AI energy copilot like we've been discussing. How can you match that together with maybe like your banking copilot or your operations copilot or something that you're using within your facility or your company to communicate with others? I know that some companies have actually created AI copilots themselves for their internal communications. So imagine having an AI copilot focused on energy be able to speak to different departments right away and instantaneously. Additionally, we're going to see more control. So give AI the ability to control processes via natural language. For example, controlling HVAC and downstream assets. So as we mentioned previously, AI is getting really good at understanding human language. So from there, we can actually create tasks associated with that. So instead of actually having to go to your computer system, your SCADA system, your BMS, whatnot, to actually put inputs or controls in, you can actually just type that into an AI agent or chatbot and then see the changes being made right afterwards. Lastly, we have integration of DERs or distributed energy resources. So you can connect DERs like energy storage and renewables into a single platform. So right now, if you have, let's say like a battery storage system or maybe a photovoltaic system, you might be looking at the data for those systems in different or separate platforms. So assuming that those platforms also have their own AI agents, they can actually communicate with one another, including communicating with what we were discussing, our AI energy copilot, to deliver further insights and further savings and carbon emission reductions opportunities. which now we're going to talk about some LLM use cases. So we've actually created a few slides showcasing what our AI Energy Copilot can do right now. But as I mentioned in the previous slide, the future of AI is very exciting. So in the next couple of months or even years, we'll see even more capabilities coming down. So the first one we have here is sample questions. So this is just, as we mentioned, being able to ask a question and get an answer back. In our AI Energy Copilot, we do have a few default prompts. So if you're not sure what to ask, we've given you some sample questions that you can just go ahead and click. And these are based off of what we've seen our customers asking our AI Energy Copilot. So questions regarding energy insights, such as provide a breakdown of yesterday's energy consumption for the facility. We can take it a step further and actually ask for consumption for each individual asset that's also being monitored. We can also ask financial questions. So how much was the total energy cost of the facility over the past month? Instead of waiting for that bill at the end of each month, as Beta had mentioned, we can actually see what that cost is for the past week, for the past 2 weeks, without even having to wait for that bill to come in or be uploaded into the utility portals. And then lastly, here we have production insights. So production and energy management go hand in hand, as we showed in our previous slides. So by being able to ask how much was the uptime of Maine over the last week and comparing that to what we actually produced, we can actually get a lot of information as to what was costing us the most in terms of production. What was not the cheapest, but what cost the least amount to produce in terms of what was happening at the same time as the energy grid or what we're paying for electricity.
So now here's an example of one of the case studies that we've done a lot of work on. So this is, give me the production schedule for the next 24 hours. So now this is asking, what are the constraints that you want us to consider? In production line 2, I want to produce 250 kilograms of material instead of the 200 kilograms that I originally told you. So now you're giving it an update on how much you want to produce. And because it's already been trained on which lines you have, how they run, your typical consumption patterns, your typical production patterns, and it's looking at energy forecasts for the next 24 hours, it's actually coming and telling you, this is how you should run your lighting, this is how you should run different aspects of your production schedule, and this is the kilowatts that each of these different devices should actually consume. And if you do this, you'll still get the 250 kilograms that you want to, but you're going to minimize your costs and minimize your emissions. Now, you could go back to it and you could say, hey, instead of 250 kilograms, I want to make 400 kilograms. Or again, between the hours of 4 and 8 p.m., I cannot do any changes from the typical consumption because of this reason. I have a customer order coming in, I have a tour, someone's coming for a walkthrough of the facility. So it really gives you that natural language communication capability, which makes it much easier to work with these models. On the back end of this, there's a lot of math and there's a lot of optimization models, but as an end user, you're just talking to it like a person and you're saying, this is the kind of insight I want, give me the answers for that.
On to the next. There we go.
So another example, I think I got to click play there. I think because it's embedded.
Oh, give me 1 second.
So another example is give me a breakdown of energy consumption by device. So it would be very difficult to find an operations manager who can tell you down to $1, this compressor cost me that many dollars this month to run, and that lighting cost me that much, and that blower cost me that much, and those machines cost me that much. It's very rare. With the IoT energy management information system combined with this AI solution, you'd be able to just ask it, give me a breakdown of my consumption by device over the past week. So I want to know which of my devices is using more. Now you could use this to compare different production lines. You could use this to compare different departments. I want to know what is my tool and die department consuming versus my production. What is maintenance using? So all of that is something that it's able to just spit out that information for you very quickly without having to fiddle with Excel sheets and databases and all those kinds of things. And it just pulls out that data. So this one was a good example. And this is real, right? So this is the real Copilot. These are just screenshots from our current in production Copilot that's able to give you these kinds of insights. So give me a breakdown of energy consumption by device last week in kilowatt hour. Then the next example, we're going to get into, you want to wait for it to load again? Or?
Yeah.
So this is the next example. So in this one, we're asking what devices are you currently connected to? So again, regular English, what are you connected to? Give me those devices. So you can see here in one of our accounts, we have dozens and dozens of energy meters, and then give me a breakdown of each device's consumption compared to the main, right? So I know that my bill is going to be X number of kilowatt hours. How much of that bill over the past week was this device versus this device versus this device? So it'll be able to then break that down for you and give you that analysis. Now you can imagine this is a lot of data processing that needs to happen, right? So what devices are you connected to? Then it has to go one by one, look at those devices, understand how much they consumed, understand the fact that we're talking about a week or a month or a day, analyze all that, do the mathematics, and then come back to you. So if a person wanted to do this, this would take maybe 10 minutes, maybe 15 minutes. But you could see here when we ask the question, the Copilot is able to pull this out in a matter of few seconds, right? Less than a minute, it's able to gather all of those devices, do all the math, and give you that final answer without having to fiddle in Excel, without having to import CSVs, without having to go to the utility and get interval data. Because it's connected to the IoT platform, all of these insights get answered for you relatively quickly. And you can see here, it's thinking. It's coming. And you can see, so now it's looking at each device, what was the energy consumption of that device over the time period, and what percentage of my main did that really make up. So you can imagine how that would be very helpful. And again, this is just the start, right? Getting this data right and getting the training of this Copilot right is no easy task. But once it's able to analyze and understand that data, you can ask it all different types of questions, and more skills and more capabilities get added on top of that base of really having an understanding of what does this energy data mean and how can I analyze it. Then there's a lot more that could happen on top of that.
We have one more here, which is our energy cost comparison example.
So in this example, instead of asking about kilowatt hours, we're asking about a total energy cost of feeder 1 versus feeder 2. So you can imagine you have a facility where there's two different utility feeds that are both metered, and you want to get an understanding of what are these lines doing versus what are these lines doing, and how much are they actually costing me in terms of energy. This will actually break down the HOPE cost. So the current version breaks down the HOPE cost. The next version, which is coming out in May or June of this year, will actually break down all of the costs. Global adjustment, all the different line items on the bill will be included in that. And you can see here, it was able to give you a comparison of feeder 1 versus feeder 2 in terms of energy costs for last week, for example.
So that sums up the examples that we have. Here we have a company snapshot. We've been growing very rapidly in the last couple of years, especially in the last couple months and year, I would say. These are some of the customers or clients that we currently work with. Some of them are also Enova customers. And then here's just some a little bit of insight as to where we are. So we have 400 or over 400 active devices deployed right now. So these include our IoT sensors that are used for downstream asset monitoring, as well as what we use to connect to utility meters to be able to host that utility data onto our portal. Additionally, we're now in over 190 facilities throughout not just Canada, but also North America. We crossed the bridge now and have also acquired some clients in the US, which has been very exciting, which leads to the next point, rapidly expanding. So not only are we in Canada and the US, but now we're actually looking towards making the next jump to Europe, which I think we'll get to in a later slide as well. So right now, our products that we currently offer is our data track solution. So this is where we get that energy monitoring, those IoT sensors and devices, being able to host that data on our portal and visualize it, also provide those insights, and being able to use the AI Copilot, all kind of fall under data track or directly connected to it. Additionally, we offer a peak management software. So this was the first software that the company was actually created on, which is called P-Track. And then a lot of customers like the idea of seeing their demand data or the ISO data on the portal, but they wanted to see their actual facility data as well. So that's where DataTrack kind of came in and how those two services kind of tie in together. And then we also have demand response, because peak management and demand response are very similar. In Ontario, one of those programs, you're actually reducing your GA cost, whereas the other one, you're actually generating income. But ideally, it is the same actions that you're performing to actually get those results, which is just curtailing or load shifting. So that's why that's there. And then as you can see, DataTrack being in the middle is what allows you to be able to visualize your data in real time to be able to enhance your performance in those two different types of programs. We did talk about the AI Energy Copilot already, and then we also have NeuroCharge. Vedad, would you like to take NeuroCharge, since I think you're a better expert in it than I am?
Yeah, so NeuroCharge is also very exciting. So we're taking a lot of the models that we've built for peak management and price forecasts and the capabilities we have in demand response and peak predictions, and bringing that into one tool that's an AI-powered DER optimization engine. So right now we have some batteries that we're dispatching throughout Ontario and in Alberta as well, that are taking advantage of all the analytics and all the data that we have to increase their revenue stream. So making sure that those assets are able to integrate with the grid properly, making sure that they're optimized for when the hope is the highest, or when the real-time price is the highest and when it's the lowest. And all those optimizations happen with our AI models. And all of these tools work together hand in hand to make each other better, right? So you can imagine how if we have facility data through DataTrack, that enables the Copilot to be much more informative and much more insightful. Having peak management data coming in from the grid side makes, again, that Copilot able to understand what's happening on the grid. And then all of it, once, which many people are, and more people are looking into this, once you've procured a DER of any kind, like a battery system, or like solar, or like smart HVAC, or again, like EV fleets, we'll be able to dispatch those and make sure that those assets are actually generating revenues for you and creating significant cost savings. And all of this goes into one platform, which is super easy to use and super easy to understand. So we mentioned it a little bit, but again, beyond the AI Copilot, what Edgecom does, peak and price predictions, DER optimization, we give you insights and recommendations, and we really take a close approach with our clients, a lot of hand-holding. The Copilot and the AI tools provide a lot of data and a lot of insights, and we're here to help facilities optimize their energy consumption. That's why Edgecom exists. And when I was an energy manager, I saw what a huge challenge that this can be for a facility. So any help you need on energy, on optimizations, and on these new AI tools, we're always super happy to help. And finally, just a little showing off here. So we were the winners of the ABB New Energy Challenge. So out of 800 companies globally that competed on an AI energy management tool, Edgecom was the winner. And this enabled a partnership now with ABB, which is a large Swiss electrical component and power systems component manufacturing company. We work with them very closely to roll out a lot of these offers. We also won a challenge with Shell, which is similar, using AI copilots to help with the electrification and optimization of some of their refineries. So that will, again, help to reduce the carbon emissions of those processes. We're also part of Third Derivative Vector Institute and Uptake.
So that concludes our presentation. If you have any questions regarding any of our services or anything we just discussed, AI especially, we'd love to hear from you. Feel free to reach out using the contact details below.
Thank you, Courtney. That was great. Thank you. Thank you for having us.
Thanks.
Yeah.
Well, I thank you both very much. This is great information. I actually have a few questions myself. Since Andrew and we deal with a lot of our customers, how would you present this to upper management? Like you go up, say, hey, we just saw this awesome webinar, and the upper management says, what's the ROI on it? Where's it? How would you calculate that? How would you present that to your upper management?
So the easiest example of the ROI is we had a customer that installed these devices within their injection molding facility. This is actually a customer out in Cambridge, right? And within 2 weeks of installing the solution, they were able to find that 90 kilowatts of additional curtailment opportunity for the demand response program and for the ICI program, right? Where did that come from? Because they didn't have real-time monitoring in the past. They were just assuming that curtailments were happening according to their standard operating procedures, right? When they installed these devices and when they did a deep dive through the data, they found out that, oh, these air compressors that we thought are running on VFD are not running on VFD, and these devices that we think should be curtailed are actually not being curtailed during the specific hour. So they were able to find 90 kilowatts of additional savings, which leads to tens of thousands of dollars of additional savings. In addition to that, the alarms and we call it fault detection and diagnostics on a typical EMIS platform. So taking a look at, is lighting being left on over the weekend? Are fans, our blowers, our exhaust fans being left on during times where they shouldn't be, right? So having that data and having that real-time visibility definitely creates ROI on energy savings. That's in addition to all the other savings you get through peak management programs and DER optimizations. And this AI brings it all together in an easy-to-use tool. So again, you don't have to be a data scientist to gather all that info. The AI will just make it much easier for a regular plant manager or facility operator to get those insights.
Cool. And so since I'm really old school and things like that, and I'm always leery about machine learning, how do you see machine learning models adapt over the years and, to better deliver outputs and insights and savings?
They've come a long way. They've definitely come a long way, but there's still, I would say we're about two years away from really, really, really powerful tools. And a lot of the work that we're doing is now on training. So now that these models have come out and these models are available, so the foundation is there, but what we have to do now is it's like a baby that you have to teach, right? So the foundation is there, it has the brain, but it's like a brain in a vat that hasn't been really trained. It doesn't have experience. It doesn't have skills. So what do you have to do? Well, you have to give it the skills and then you have to give it the experience. So as it gets more feedback and as it gets more interaction with real users, it gets smarter and smarter and it gets experience of how plastics facilities like to operate, of how food processing facilities like to operate. So that experience component is something that only humans have. But a lot of the work that we're doing is training these models to get that experience and to then over time, they'll be able to actually predict what your next question is going to be and become much more useful and much more powerful. So we're getting there. We're taking baby steps, but I don't think we're anywhere close to Terminator yet. And it's funny because the closer people are with these LLMs and these models, the more that they know that we're pretty far away from that kind of understanding, right?
So one last question. So with the utility, we take privacy and data privacy very seriously. Is there anything in place for AI or energy management AI?
Of course. So there's a couple of different things. I mean, when it comes to cybersecurity, we have the highest protocols that you could possibly want to have. We're working on SOC 2, ISO 27001, OEB, the Ontario Energy Board has their own regulations that they expect energy companies to abide by. So there's a lot of work being done in cybersecurity when it comes to energy data. It's critical infrastructure, so obviously that's something that we take very seriously. Now, with that said, a lot of the processing and a lot of the analysis actually happens, can happen on site. So if customers are interested in having edge solutions, they don't want any data to go into a cloud and come back. There are cases that we're working on where you could actually have the LLM running locally inside your plant, right? So then that way there's no consideration. But even with the cloud-based solutions, right now the way that we built the systems is all the data is anonymized, and it's basically just the translation layer that's happening by the LLM, but the rest of it is happening through more traditional machine learning, which keeps that data security super high.
Perfect. Well, thanks so much for answering my questions. We only got a couple minutes left. So Deepak is asking, what are the energy monitoring devices you are installing? Are those submeters?
Yeah, so we have these, they're super cool. So they're these, they're wireless and they're batteryless clip-on CT meters, right? So these use a technology called LoRaWAN, which is a long-range, low-frequency bandwidth. And we've done a lot of testing on these in industrial sites, and they're very inexpensive and very powerful. So you clip these CT devices onto your compressors, your boilers, anything that you want. They connect to a gateway, which then that gateway is connected to the cloud with LTE, and that data then starts streaming in. And the beauty of these is because they're self-powered, you don't even have to worry about battery changes or anything like that. And because they're wireless, you don't have to worry about running Ethernet through your plant. So those are the IoT devices that we're currently using, and these are Edgecom's proprietary devices. So we do work with an OEM, but we've done a lot of work on customizing the firmware and customizing the connection protocols that these systems use. They're super cool. I wish I had one here, but if you check out our website, you can see a picture.
Awesome. And I know we're running very short on time. This is awesome. I thank you both very much for your time and your insights. If we have any further questions, or if the customers have any further questions, again, contact information is on the slides that we're going to share later. And you can always contact either Andrew or myself, and we'll make the introduction that way. So thanks again for your time, and have a great day.
Thank you, Chris.
Likewise.
Thank you, Andrew. It was a lot of fun.
Thanks, guys.
Thanks very much,
Appreciate it.
everyone.
Thanks, everybody. See you
Thanks.
next time.